This is an instructional video on how to make a time-lapse slider. As part of the TJC circuits class, we were given the assignment to make a time-lapse slider. The previous class had made one that failed in certain areas to operate correctly, and we were tasked to design one better that enhanced on their design flaws. So the first thing that we had to try to make better was their system had a screw drive to pull the assembly along. And we were going to use the same motor that they provided to us and design a way to pull the slider along in a more efficient way. So we decided to use a pulley system with a belt. Okay, so our time-lapse camera is going to be sliding across a rail, which is a T-slide extrusion made by 8020. We had ordered it. It's prefabbed at 48 inches. And it has slots that allow for Teflon sliders to go through in the rail system, which kind of locks in place and allows for smooth sliding. The belt that we had already covered previously when talking about the motor attaches to these plates, and a part of our design is we drilled holes and threaded screws so that we could attach these end plates. So these end clamps that we just cut from a piece of aluminum, we drilled holes in so that we could mount it. We used window locks that fit perfectly with the belt clamp to be able to affix the belt to the end plate and hold the system steady.
Alright, so one of the next things we had to address when building the camera slider was we had to have something for all of our equipment to sit on and be transported up and down this here rail. So we mounted these mounts that are basically going to hold our rail onto our T-slot rail. We mounted the little Teflon bearings here that fits in the slot, so it'll allow smooth movement. You can see the movement is smooth. The bearings help keep the dolly aligned. It doesn't allow for any unwanted movement side to side or up and down. The motor will, as said before, pull the cart up and down the slide. And whenever the cart reaches the ends, there's these little limit switches here. Whenever one of them is pushed, it tells our control box that we'll be using to stop moving in that direction and move the other way. We have one on each side. They're hidden underneath here so they don't get hit by anything that we don't want them to get hit by, so they don't get messed up. And then we've mounted our idler pulleys directly to the cart here. The configuration we chose to use, we'll have a motor mounted on the other side here with our pulley going in this hole here. With the belt attached, it'll go in a configuration like this, which actually allows for the motor to hold the cart in place so we don't get any unwanted movement up and down the track. This will lock it into place whenever the control box tells the slider to stop. So next we have the control box for the system. It's called an intervalometer. It's a open source project that we actually got from a website that we'll post in our links. The whole thing runs on Arduino. There's an Arduino Uno. There is a Eric Lens intervalometer chip, a big easy driver that powers our motor, and an LCD keypad so you can navigate the program. The It's got a custom-made box that was printed in a 3D printer, so everything fits snugly in there. We've used several connections here. These are where our limit switches plug in here at the bottom. Where power goes in here, it'll take from 9 to 12 volts. This is a 3/32 jack. You actually use a little cable that'll go from the box here to your digital camera. Works with pretty much any DSLR camera. This plugs in, this will control your shutter and your focus. Here we have a 4-prong aviation plug that the motor plugs into. It's a screw connection, so you don't have to worry about the connection coming undone for any reason. Once you plug it in, you screw it in, and it's a tight fit there. We've got Velcro on the bottom. It sits snug on our dolly here. You can pretty much put it wherever you want. The little camera mount here, your camera will sit on. You've got plenty of room to plug your cable in there. And then your limit switches. It doesn't really matter which hole the limit switches go in, as pretty much either one gets switched. It'll tell the control box to stop going and move the other way. There's not a left or right switch. Other than that, we power the thing with a 12-volt battery pack. You can use any one you want as long as it can use a standard, I think this is a 2mm inner diameter by 5.5 outer. That'll plug into the box right here. So a lot of good information on how to use this on Eric Lenz's website, which we'll put in the link. But this powers the entire slider. Okay, so this is the full project set up and ready to go. We have the camera mounted here to our little camera mount, which you can, use any camera mount you want. This one's adjustable pretty much any way you want it to be. We have our battery here, powering our control box here. I've got it set up on some basic settings, basically to move a little bit, stop, and then take a picture. As you can see, whenever we turn it on, it'll move just a little bit. It'll take a picture every 5 seconds or so, and you can make your settings take a picture however long you want them to. Whenever you're done, as far as how long you want this thing to go and how long you want it to slide, you take all your pictures, use whatever program you want to combine them and form them into a movie, and you get a time lapse.